Shout out to Miss Eng for being the best math teacher that there is. And math is easy. Just like 1 + 1 = 2.
Multiple choice. Oh, yeah, number 4. Multiple choice. Given 2x + 5, write the 0 that corresponds to each factor. This is a factor. And common hint is a lot of times when you're factoring, the factor has parentheses around it. That's why I just drew that. To find the 0, you're going to set it equal to 0. Subtract 5, divided by 2, x equals -5/2. This is a positive 5/2. That's wrong, wrong, wrong. So the answer is E. Question number 3, you're going to just go the other way. Given x equals -4, so this is called a 0. This one was a factor. So in a 0, write the factor, get this to be a factor with those parentheses, or get it equal to 0. So I have x equals -4, add 4, x + 4 = 0. That would be choice C. Tells you to factor completely there. Remember, to use Xbox, you have a couple of conditions. You have to have, number 1, a trinomial, which means an A, B, and C value. So here you only have 2, and then even if you did add a placeholder, the second condition is that you have to have half of the exponent. Half of 3 is 1.5, and you don't have that there. So therefore, you cannot use that. Therefore, if you have a binomial on your flowchart and you can take the cube root of each of those, then you have, in this case, the difference of cubes. Difference means subtraction of cubes. Well, what is a cube root? And now, if you use your calculator, mine's going to look like this. Math, and then go down to number 4. And then you can type in a number such as 64. Remember that number there is 64, not -64. And you get 4. So the cube root of y to the cube is y. Or another way of saying it is y to the 3rd power is y cubed. 4 to the 3rd power equals 64. Your A value is y, B value is 4. The formula for the sum and difference of cubes is always going to be the same. A, B, A squared, A, B, and then B squared. And then the math operations start with what you have. So this one is a minus sign. So you're going to have SOAP. Same, opposite, always positive. And then you just substitute it in. And my A value is y. My B value is 4, not -4. A value is y, so y squared gives me y squared. A times B, 4 times y is 4y. And then B is 4, so 4 squared is 16. This is your answer. That would be choice A.
Factor completely, you should always, I loved it because one student actually just wrote this. GCF. Every question that says factor, they just wrote GCF. Good idea, good idea. It does have a GCF. The GCF is, go a little quickly, faster, is 6x cubed. Remember, if you expand them all out, 6x to the 5th, there's 5 x's, 4 x's, 3 x's. You'll notice that they have a 6 and 3 x's as greatest common factor. If you got to this point right here, then I gave you, I think, 3 points off. You got a 2 if you found just a common factor. Here in purple, if you make your X box, A times C is 3, B value is -4, your two numbers are -3 and -1, and they go there. So you would have to have this as full credit. Question?
Factor completely, and then extra credit if you can factor over the complex. So it just tells me to factor. I need to make sure I show all your working box or answers. I have 4 terms here. 1, 2, 3, 4. That should be a giveaway. Let's try factoring by grouping. And to remember, found it super helpful to write them in the form of a z here. So let's go ahead and do that. X cubed minus 2x squared plus 5x minus 10. And then I'm just going to take out the greatest common factor, so x squared, x, negative 2, and then 5. And that can double check my answer, right? X times x squared is x cubed, negative 2 times x squared gives me negative 2x squared, x times 5 is 5x, negative 2 times 5 is negative 10. So my answer is going to be x minus 2, x squared plus 5. Let's find a color. How about red? Okay, so this is called factoring over the real, because all of these are real numbers. Now, if you wanted the extra credit, you would have to have done the x squared plus 5. So x squared plus 5 equals 0. And a complex just basically means you need one I in there. You could use a quadratic formula, a lot of work. X squared plus 0x plus 5 equals 0, and those are a, b, and c, and put it into the quadratic formula. Or you should just recognize this is a square root problem, so subtract 5, x squared equals negative 5. We're going to take the square root here. X equals, pay attention, you need both a plus and a minus, the square root of negative 5. And then the factors of negative 5 are the square root of negative 1 times the square root of 5. This one becomes plus or minus I, and then square root of 5 you cannot simplify. So your answer is x equals plus or minus I radical 5. There's a couple of reasons why this works. Let me show you guys the answer. So I'm just going to take x minus 2. And then remember you have x minus, and then you'll have one of these to be positive I radical 5. And then you do the negative I radical 5. And then to clean that up, your answer would just be x minus 2, x minus I radical 5, and x plus I radical 5. And this would be factored over the complex. And this makes sense because the fundamental theorem of algebra tells us the number of zeros based on the exponent. So this is a power of 3. 1, 2, 3. Now, this tells you there's one real, and then there's actually two imaginaries. How do I know that? Because if you solved over the complex, this is one real, and this is an imaginary, and this is an imaginary. So 1, 2, 3 zeros. So if you wanted the extra point, then you would have to have had this as your answer. Given x to the fourth minus x squared minus 12, factor completely. So I have a trinomial. 1, 2, 3, that's an a, b, and c. And if I can take half the exponent, let's see if we can take half the leading exponent, x to the fourth, so the fourth, half of 4 is 2. This is good when both these conditions work. You can use x box, so let's do x box. Your a, b, and c, your a value is 1, so a times c, and 1 times negative 12 is going to be negative 12. And then my b value is going to be negative 1. Two numbers that multiply to be negative, or 12 is 4 and 3, and they need to add to be negative 1, so this one is going to be there, negative. Negative 4 times 3 is negative 12. Add those together and you get negative 1. Now let's say you don't know the shortcut. Just take those two values. They will always go there. Remember they're splitting the middle term. So the first term will always go into the top left. The yellow here, -4 and 3, are splitting -1. So you have to add an x squared, and the last term -12. Just take out your greatest common factor, x squared, -4, and then +3. And then double check by multiplying, and that works. So to factor completely, I have x squared -4 and x squared +3. But here, if you would recognize, you have to factor that one again. And that's why I drew a kind of a big space right there. If you had put a 0x here, you would have gone a times c is -4, your b value is 0, and your two numbers are 2 and -2. So to factor the red, it would be x plus 2, x minus 2. And then this one would just be x squared plus 3. What was the shortcut I was talking about before? Remember, when you're doing this x box method, you only have to do the x when a is equal to 1. If this number is greater than 1, you have to do both x and the box. So to summarize, a is equal to 1, just use the x, and if a is greater than 1, you have to use the x box. But if you forget and don't know that shortcut, you can actually do both and get the same answer. Alright, second step is now find the zeros. How do I find the zeros? Well, these are called factors. I don't know, an obvious way to kind of explain that is they have parentheses. To find or identify the zeros, or solve for the zeros, or just solving, I'm going to set each of these equal to 0. And then you just basically solve each one of these. Subtract 2, x equals -2. Add 2, x equals 2. Subtract 3, x squared equals -3. How do you get rid of the power of 2 there? You have to take the square root. We talked about previously, if you take the square root of an equation, it's plus or minus. And then you have the square root of -3, and the factors are -1 and 3. Square root of -1 is I. So there, this 0 is x equals plus or minus I radical 3. Again, the reason why you have to write that plus or minus is because now if you take one of these, something like I radical 3 squared, I squared is -1, and -1 that becomes the square root that becomes the I radical 3 squared would just be I radical 3 times I radical 3, which is I squared times 3, which is -1 times 3, which is -3. So that proves to you, not in the red, but if you put in positive I radical 3 or negative I radical 3, it'll equal -3. So there's two answers that you can put in for x. Squared will give you -3. Okay, sketch the graph. Sketch it. Use my straight edge. I'm going to write the original problem down here just so you can see it. X to the 4th minus x squared minus 12. Alright, so -12 is my y-intercept. Let's write -12. And it's to the power of 4, so it's an even degree, like a quadratic. Starts up, ends up. leading coefficient is positive, so your arrows stay that way. And then I'm going to take x equals -2. Let's see what colors I got. And then x equals 2. Okay, now remember this is on the x and y coordinate, so this is the real number system. So there is no I in radical 3 on the complex, so you can just go ahead and sketch it. Now I should show some kind of turning point or extrema to there. Why is that the case? Remember the degree 4 is equal to the extrema minus extrema equals degree minus 1. We learned that previously. Extrema equals degree minus 1. So if I have 1, 2, 3 extrema, and you add 1 here, you get a 4th degree polynomial. So that basically is telling us in a 4th degree polynomial, you have to have 1 less for the extrema. So if I just went here and did a quadratic, I wouldn't have enough extrema. And then that's how you graph your, looks something like this. Doesn't look exactly, but it's a W, and you should have 3 turning points.
I'm Mr. Eng's mom. Do your homework.